Do you have too many material combinations to test physically? Or do you struggle to ensure the required spot weld quality and strength? Or are you lacking the time needed to engineer a safe and robust weld process? And does this result in time-consuming physical testing, high material and labor cost, suboptimal weld quality, over or underestimation of weld strength, or long feedback loops? Then it's probably time to switch to the Keysight CAE welding solution for weld rupture analysis. Keysight CAE welding for weld rupture combines over 25 years of proven welding and performance solvers with a simple, intuitive graphical interface. This interface supports both detailed spot weld process modeling and the performance testing required to assess connection strength under various load conditions. The solution includes an extensive material database for welding and rupture, automatic weld load generation to determine valid operating windows for process parameters, and contains standard rupture test specimens for coupon level strength analysis. First, the spot weld process itself can be validated. Stacks of up to 4 sheets can be investigated, and material parameters are retrieved from the integrated material database covering material data for both the welding process part and the rupture part. For the most commonly used metals in the automotive industry, electrodes can be selected from the internal library or defined manually if required. The input parameters for the welding simulation come directly from the real process: current, time, forces, preheating, and number of pulses. Directly following the weld simulation, an automatic summary becomes available. It includes detailed information on nugget radius and height, spatter risk, microstructure around the weld, size of the heat-affected zone, and more. Because real-world welding conditions always vary, the software can also perform weld load prediction. This can be done in the classical matrix form, showing, for example, force versus current variations and their influence on nugget size. Alternatively, a continuous weld load can be computed using model order reduction, enabling real-time visualization of how changes in force, current, or time affect the final nugget radius. For the rupture analysis, the nugget characteristics obtained from the welding simulation are automatically transferred. 5 different coupon specimens, such as overlap, T-tension, or lap shear tests, can be selected and defined with the appropriate width and length. The output includes force displacement curves, which is today the standard input for crash simulation tools and usually obtained through physical testing. When combined with Keysight's performance simulation environment, accuracy can be increased even further. Instead of importing just force displacement curves, the actual 3D spot weld models from the welding simulation can be automatically embedded in the crash analysis at critical weld locations where rupture is likely to initiate. Keysight CAE welding for weld rupture is a complete environment for spot weld process validation and connection strength assessment. It enables you to use your specific electrode configuration with material stack of similar or dissimilar materials. Use real physical welding parameters. Obtain nugget radius, spatter risk, and weld load predictions. Quickly evaluate rupture strength through dedicated coupon models, and seamlessly integrate results into crash performance simulations. By applying Keysight CAE welding for weld rupture in your engineering process, you can eliminate dependency on physical testing, scale your engineering effort efficiently, increase productivity and process robustness, accurately assess weld quality and strength, improve crash performance predictivity, and develop a safe, reliable weld process that achieves the required nugget size, avoids spatter, and delivers the expected connection strength. With Keysight CAE welding for weld rupture, you transform spot weld development from slow, test-driven iteration into a fast, predictive, simulation-based process.